Wastewater Dan presents wastewater math calculated with Excel spreadsheets. As a new service of ESDLT's Environmental Academy, environmentalacademy.com. Today's example, calculate percent of side stream suspended solids to secondary treatment influent of solids. So the problem reads, the influent flow to a secondary treatment plant has a primary effluent of 4,791,667 GPH with 123 mg/L suspended solids and a side stream of 0.97 mgd with 1,458 ppm suspended solids. What percentage is the side stream suspended solids to the influent load of secondary treatment plant? Now this is a percentage problem, and the structure is very similar to an efficiency percentage problem. And that is that we take the value that we want to base the percentage on, and we divide it by a combination of relevant values. An efficiency problem, it's going to be the net of the in minus out. In this problem, it's going to be the sum of all of the values of the solids entering the secondary treatment. That will give us a decimal equivalent, and we will multiply that by 100, which will give us a percent. So after we get the formula set up, we realize that everything that we put into this formula is solids, and solids are not included in the data in the problem. So we need to calculate solids for each one of these data points. One data point is the primary effluent solids, and the other data point is the side stream solids. Now I have previously published videos for calculating solids for each of these data points. So I'm going to refer to the video. I'm going to give you the URL, show you the formula for each, and then we're just going to insert those values into this formula for today's problem. So the two data points that we have to calculate the value of poundage for is the primary effluent suspended solids, and because we have to have a common time element for the poundage calculations, I'm using pounds per day for each of these calculations. So the pounds of primary effluent is this bottom URL, and the answer is 117,969 pounds. And the calculation of pounds of side stream solids, this is the URL in the formula. This answer is 11,795 pounds. And so what I'm going to do is insert those values into our basic formula. So the basic formula is percent side stream to total influent equals the side stream pounds divided by the sum of the primary effluent solids plus the side stream solids. And then we'll take that result, which is a decimal equivalent, we multiply it by 100 to convert it to a percent, and that's going to give us our answer as a percent. So the numbers are 11,795. As the side stream solids, we're going to divide that by the sum of the side stream solids plus the primary effluent, which is 117,969 plus 11,795. We'll take that result, multiply it by 100, and that's going to give us the answer. So let's look at how we insert this into an Excel spreadsheet. If you go to a blank spreadsheet, you go into, put your cursor in cell C1, type in this answer, percent side stream solids to total secondary influent load. Put your cursor in A1. You can format it as numbers with 1 decimal. You can make it bold and centered, and then you can put your start typing in the formula bar this formula. You put equals, equal sign, open parenthesis, 11,795, close parenthesis, division key, 2 open parentheses, 117969, close parentheses, plus sign, open parenthesis, 11,795, to close parentheses, multiplication key, 100. Then you can press the enter or the return key, and your answer will be 9.1. So that's the answer. 9.1 is the percent that the side stream solids is to the total secondary influent solids, which includes the primary effluent and the side stream solids. So I hope you found this video to be educational and helpful and useful. If so, please subscribe to my YouTube channel. I also encourage you to participate, interact by submitting, by commenting or submitting a question. You can do that through my website, environmentalacademy.com. I also will be publishing videos at least once weekly, so please come back often. And thanks for listening, and see you again.